Okay class, let's continue with the second part of the video for normalization. What we call as unnormalized data. Okay, unnormalized sample data is actually known as the database or the table which is not normalized yet. Okay, this one is a sample case. A cyber cafe wants to capture data about its member. Okay, the logbook is used to record down the following: entry number, member email, password, name, phone, in time and out time. So you can see here. So this one is known as the entity, and these are the attributes: ID, email, password, first name, last name, phone, date, in, date, time, out. Okay, and if you notice that 002 and 004 are repeated, this one and this one is repeated again, 001 and 003 is repeated. So when you found this kind of repetitions, what we call as redundancy, remember, redundancies means repeated records present in the table. So when you found the table, repeated records in the table, that is known as an unnormalized sample data or unnormalized data. Generally, unnormalized design causes three anomalies. Anomalies. I told you right just now, anomalies. Okay, so the first anomaly is update anomaly. Update means when we try to modify, also known as modification anomaly. Update anomaly, also known as modification. Okay, when the password for the Tom Lewis was changed, it was not changed in both of his entries. Which password is the correct password? If you notice here, you can see this box, the first, second row and then the fourth row. The password for the first 002 has been changed. 004 has been changed. Should be this one is the latest one, right? So this one has been changed. But why it is not changed, though it is the same person? So which one is the correct one? So this is what we call as update anomaly or modification anomaly. So when there's one part of the data is updated, the other same record not obtaining the updated part, the latest version or the updated version of the record. So this is what is known as modification anomaly. Hope you guys are clear about this. So once you normalize your design, eliminates the update problem. So what we will do in this case, we try to separate the record of members and the record of visit into two different tables. See, we have a member table and we have a visit table. So inside a member table, we don't have to repeat the same record. Everything is a single atomic record. It's known as a single record, which means there is no any multiple values are present in a single row. So this password is already changed. So now when you make a changes over here, for example, in any of the row, it only changed directly in one particular row because there is no any repeated records here. Every records are in member table are not repeated. They are single atomic records. So when you modify, the modification is obtained without any issue. So we already eliminates the update problem or modification anomaly. Okay, clear class? Let's go with the second problem. As I told you, there are three anomalies. First anomaly is update or modification anomaly. Second is insertion problem or insertion anomaly. Okay, so if you see here, you wanted to, a new member cannot be created unless they have already made a visit. Otherwise, there would be no primary key value. The field may not be left blank. If you see here, you cannot enter a record for new member in this table. Why? If the member never visit the cyber cafe before, you cannot enter the member record. So in order to we add a new member into this table, we must make sure that is a visit ID. You can see visit ID is the primary key. You cannot leave the primary key as a blank or null. Okay, this is wrong because it's a primary key. Primary key always not null values. So you cannot insert new record. Insert means it's very simple again. Same like modification. So modification anomaly, when you modify that, there is a problem because one record is changed, the other record is not changed. But when it's come to insert problem, okay, you cannot insert new record without you get this particular primary key ID. Okay, you cannot create a new member, so that is what we call as insertion anomaly. So if you want to insert new record, you can split the table and normalize the table. For example, you separate the member table and you separate the visit table. Now you want to enter a new member called Raymond Ross. Okay, you can directly enter here. Here for this particular table, we don't have to require it. It is not required to have a visit ID. You don't have to have that because for member, email is a like kind of registration and also the primary key of the table. So this table is normalized. And third problem and the last problem here is deletion anomaly. This is the most easiest anomaly that you can identify. Class, why I'm talking about these anomalies, there is a final exam questions. It's about all these three anomalies. Okay, you're supposed to able to answer what is insertion anomaly, what is deletion anomaly, and what is modification anomaly or update anomaly. Modification and update is the same. Okay, delete records. When we try to delete, if a member make only one visit, deleting the record will cause the loss of the data, member data. Okay, for example, 005, this record, you try to delete this record. Saint Megan, okay, Saint Megan is the new John we have twice, Tom also we have twice, only Saint Megan. Okay, Sean Megan is the one got single record. So which means that if you delete this particular record, you will lose information about the member because you wanted to delete the visit ID. You want to delete the visit ID here, but unintentionally you deleted the member record over here because the table is not normalized. Your intention to delete visit ID, but unintentionally it deletes the member records. So that's why it will cause the loss of member data. For example, there is only one record that indicate Sean Megan's member data. So if we had to delete 005, let's say we got the date wrong. Okay, this one, they said, just imagine. So if you want to delete 005, then we will lose all informations about Saint Megan. Okay, so these are what we call as deletion anomaly. You delete one record unintentionally, you delete two records or three records from the same row deletion. Okay, so how we normalize? Once we normalize, which means we separate the table, two table already, and now you wanted to delete 005. For example, you delete here. Deleting 005 would not cause the loss of Sean Megan's member data. You delete here. Does the member record for Sean Megan is deleted? No, it is not deleted because this one is a separate table and this one is a separate table already. So deletion problems won't occur when the table is normalized. Remember class, try to recall back. So all the three anomalies. Modification anomaly, when you modify a record, it causes issues or problem. Second, insertion anomaly, without primary key you cannot insert new record because primary key is different for that particular data and database or table. So you cannot leave it blank or null. Usually primary key always not null value. Okay, and third one is deletion anomaly, which is we try to delete one particular record, it will delete another record unintentionally, so you will lose records more than one. Okay, so that's all about anomalies, huh? So we'll continue with the first normal form, how to normalize the table, the process of normalization, the step by steps I'll cover for the part 3 video. Thank you.